Welcome viewers. Today we are going to see how to create a linked list and insert and maintain the sorted order. Now how we have to do that one, right? The linked list node is having the data followed by a link, right? So here we are having the data part and followed by a link part. So the data part, another one, the next part. The next is referring another node or otherwise none. None means nothing, none, right? Now, while creating a single node, then you have to use that create an instance of node with the corresponding value, right? Now the value data is passed on to the data part, and the next is going to have as none. While creating a single node, the link is having none. Now this is the node, initial node creation. Now that node is going to be inserted into a linked list in the sorted order. Now here first you consider you are starting a new linked list through that init self get is none. So here we are going to create a linked list. For that linked list, the head is initially none. Head is none. So this is actually the linked list with empty node. Now here we are going to insert a node. Now for inserting a node, we have to consider three possible cases. One case is actually a linked list without any element. Otherwise, a linked list is having a set of element. Linked list is already having a set of element. Then on that linked list, you are going to insert a node. Then for that insertion, we are having three possible cases. One is in front of that node, right? So in front, first the element may be in the first position, maybe in the first position, or otherwise in the last position, or in between, middle, right? So we are having three possible cases. So as a first element, we are making that inserting that element as a first element, or in the middle of that element, right? Or otherwise at the end of the element, right? So if the element is smallest, then you have to insert that element in the first element. If the element is mid of that list, then you have to go for middle. Then if the element is biggest element than already existing, then it will go for end, right? Now for inserting the first node, then you have to insert into head node, right? So here you have to insert. It's a first node, right? If it is a last node, then here you are having already none, so you have to add that node. It's like insert again. So in the middle, if you want to insert, then you have to do something, right? Now how? So you have to consider all possible cases. Now you are seeing that one. First you are having a linked list is none, empty. Then we are going to insert one new node. The node is, you are creating a node as 5 with this is none. Now what we have to do is the self get is going to have that 5. So first you have to check possible cases, right? So now here current self get is going to be referred by two more reference. One is head, another reference is previous, right? Head previous, another one term. We are having that tree is going to refer this one. So all are currently none, right? In that possible cases, right? Now here temp is none. So this while loop is not execute. This while loop is not execute. Then what it will happen here? Now it will check previous equal to none. So previous equal to none. So previous equal to none means then you are consider no node at all in the list. So now the current node we are going to have as a self get. So that node, whatever node we are having, this is a node. This is passed on by this function, right? So here insert. So node 5. So node is going to have a limit. So none is more, right? So one node is created and inside. Now this node is inserted and here we are having null. This is the case. So it will execute this part. If it is the case of already the node is empty, now we are going to insert a node. So whatever node it may be, that node is going to have as a first node. Next, here suppose this already is there. Now you are going to add one element is less than that size. So we are going to insert the element with that value data 3 and this is none. Now you want to insert here. Here that node 3 is actually less than that 5. Now what it will happen here, right? Now the self get is not none. So the self get is here something. So everything is showing now. So here now this is while term, now the term is not null. So now it will enter into here. Here now the term data is here now 5. Then node data is 3. Here 5 is greater than or equal to 3. So this condition is satisfied. Now it will break. It will break means this while loop come out of this while loop. So it will come to here. Whether the previous is none, previous is currently we are having something. So previous none, this condition is not satisfied. Now the previous equal to term. So the term and the previous is showing the same element. So this is what we are going to insert as a first node before that self get. So what we have to do, node next equal to term. So now the term is self get, right? So this one is going to have as the node next. Node next is self. So here node next is here. What we are having now, the node here now what we have to do is this. Okay, now previous equal to none. So here now this one is what we are having now, previous equal to term. So this condition is set, previous equal to term. Now the node next equal to term. So current node is this node we are going to insert. This node next is going to make as term and this node is going to have a self get. So now we are inserting in front of. So we are removing this link, right? Now what we are having now, the self get is assigned here, and so that one is going to have through this statement, right? So previous equal to term. So previous and term are same. Then this condition is satisfied. So we have to insert the current node in front of 5. So in front of 5, what we have to do is this temp is showing now this one as here now, right? So now the temp is going to have as a node next. So this is we are making now connectivity, and then the node is going to have as current self get. So this node is insert in front of 5. This is the other case, right? Next case is here. Suppose this is already existing, right? 3 and 5. Now we are going to insert node 8. We are going to insert node 8. This is now we want to insert. Now what we have to do is here we are going to pass now, right? So now here this condition is, so here we are having now that self head everything is showing now that element 3. Now here what it will happen here, this condition. So this is 8, current term data is 3, the node data is 8. Now this condition is not this condition, okay, 3 is greater than or equal, the condition is not satisfied, right? The condition is not satisfied. Then what it will happen here, previous equal to term, then term equal to term next. Now the term is going to move. So the term is going to move to 5 and this is act as a previous. This is previous and this term, the previous term is moving, right? So here previous equal to term, the term next equal to term, right? Term next equal to something. So we are moving the 2 pointer, previous and term, move one level ahead, right? So this is now currently term, 5 is currently term and previous is 3. Now here once again we are checking now the condition. So now this is a term equal to 5. So 5 and 8 is compared. Now also the condition is not satisfied. 5 greater than or equal to 8, condition not satisfied. Now here what it will happen here, the previous equal to term. So the term is going to have as this one, term base going to have this one. This is make as previous. So 5 is previous. Now this term next is going to have a term is going to have as a none. So this while loop come out of this while loop. Now whether the previous equal to none? No. The previous equal to term? No. Then it will come to here. So we are going to insert the node at the end, right? So here node at the end means that this is the previous. So the previous next is now this is the current node we want to insert. So the previous is this one. The previous next is going to assign here. That's all. Previous is next is going to assign here. Then here and the node next is previous next. So node next is previous next. So the previous next is this null. So the node next also making null. So now we are having 3, 5, 8 in the sorted manner. Now in between. So if you are having that in between now, so if you are having now that element we are going to add. Suppose it is a 6. Now you want to insert. It is a 6. You want to insert. Then what we have to do? So the 6 is we are going to have now. We have to move the previous next up to here 5. Right? Now this one here, this is a previous, this is a term. Now this condition is satisfied. Now it will break. Now while breaking now what we have to do is this one, right? So now this is a term node, 8 is a term node, and 5 is a previous node. Now the term, right? So previous next is 8. So now we are disconnecting that link and we have to make this as connect, right? Now this statement is going to and then the current node is going to have as a previous next. Now this link is cut and we are making. Now what we are having now, self cut is 3, 5, 6 and then 8. So this node is, we are making that one as remove. In that manner, we can create and insert a linked list in the sorted order. So now we are having the self cut is going to have as self cut is this one. Self cut is showing that 3, 3 to 5, 5 to 6 and 6 to 8. So this is a program for inserting node in the sorted order. So we have to consider all possible cases. Thank you viewers. We will meet in another lecture.